Okay. So far we have completed the very basic two operation, which is add and sub. You have four types of add, you have four types of sub. Add address, add immediate, and add quick. So we are going to proceed to two more arithmetic operation, which is the multiplications and division. Right, you have to bring out your slide, you have to bring out your calculator, you have to start, open up the PC, you have to run all the simulators. Okay, let's start. Arithmetic multiplication is very simple in mathematics world, but in the operation here you need to understand. You need to understand the concept in the microprocessor. Alright, let's start. The operation is multiplication. The difference now is you have two types of multiplication. One is unsigned. They call it unsigned. Unsigned. In bahasa is tidak bertanda. And the other one is signed. In bahasa is bertanda. So what's the difference? So we go for MULU first. MULU means multiplication, multiply, unsigned. Okay? So the big thing over here you need to understand back. This is basically back to your first year. So if you do not remember your first year, this class you are not going to understand. So now is multiply unsigned. Unsigned means the number which is only positive number. Okay? So means that in the computer world, it's very easy for you to convert to positive number. But for the negative number, the computer has its own interpretation of its own format. If you can go back to your first year, you learn back how to convert a number, a negative number, to the second complement number, which is a number representing negative number. Because in computer there is no dash, minus, tak ada. Okay, so we go for the easiest one first. Okay, this is multiplies unsigned. So positive, very simple. What does it mean? Operation multiplies two unsigned, operand yielding an unsigned result. So positive times positive equivalent to positive number. So it's very straightforward. So the next one, multiplier and multiplicand are both word operands, and the result is a long word operand. So what does it mean is, the process will multiply words times word. The result is going to be long word, and it will save to the last destination. Okay, the command is very simple. Okay, a register operand is the lower word, is the lower order word. The upper word of the register is not doesn't matter. This command is MULU, multiply unsigned. The command is like this. MULU is multiply unsigned. Okay, size must be word only. So the machine code format is must be in the data sheet again. I keep telling you, all the data sheet will give you this machine code format. So all codes or all syntax have its own 16-bit. So no matter what, when I ask you how to generate the machine code for any code, you have to refer to the right data sheet. Okay, this table is included also in the data sheet. Let's move on. Alright, so So you have the slides. Let's try to write down 5 minutes the comment. Okay, 3 to 5 minutes, faster. After you finish writing codes and you compile first, compare with your slide first. I have to read mine. Look at the others. So compile first, look at the result in the slides, compare first. You have to comment out one by one. The last one is maybe got problem. Check the first two first. So I'm including matrices. Let's look at the answer first. From the simulator, it's very simple here. So multiply unsigned hash 3. Hash 3 is a decimal number. Without dollar sign is a decimal number. So it doesn't matter. 3 in decimal is equivalent to 3 in hexa. So you have to use word size again. So 0003 times 00A0 is because of at Q1 the word size is 00A0. The answer is very simple. From your calculator, just multiply it. You get this answer. Put back to the D1. That's all. Okay? Next one. Multiply unsigned D3, D2. So take words from D3. D3 is given 0003 times D2 word size. D2 is given FF00. So you times these two numbers, you got the long word result. That result will be put over here. The last one, I think you have problem.
Yes.
It's a syntax error. I think it's too big already. It's outside for your calculator. So it doesn't matter. I will try. If there's a test, I will not put very big numbers. Okay, right. Easy, eh? This part very easy. Alright, let's move on. So before that, this is for the machine code for each of them. The machine code you have to convert based on the data sheet again. That's all. Next one. This is one of the confusing parts. So let's look over here. Here, listen carefully. Now you are going to use sign multiply. Sign multiply means you are going to multiply a negative number. Okay, multiple sign means you are going to multiply a negative number. Sign means it can be positive, it can be negative. It can be both. Multiply unsigned. Unsigned means is only positive values. For sign, you are allowed to have a positive values. You also allowed to have negative values. Both values are okay. But now, when you use multiply sign, you have to know that from that particular word size, is it a negative value or positive value? You have to know. Okay, let's try and run this one first. Okay, let's see. Operation multiplies two sign operand yielding a sign result. Positive plus times positive is positive. Positive times negative will be negative. Vice versa. Again, the same one, multiplier and multiplicand are both word operands, and the result is still a long word operand. So it means that still W times W is equivalent to L. Right? Both of the word operands are in seconds complement form. Okay, this is a big one. A register operand is the lower order, so this is the command, multiply sign. This is a command, and the word, this is the 16-bit syntax, 16-bit code, and then this is the table for the data sheet. Okay, let's try and look at the slides. Okay, run this one first. So let's look at the slides. Select carefully. See carefully, eh? The first one very simple first. Let's go for the simplest part. So multiply sign #3 to D1. #3 is equivalent to decimal 3 and also equivalent to hexa 3. 3 is a positive number. That number is a positive number. It's because of the MSB is equivalent to 0. 3 is equivalent to 0, 0, 1, 0. Sorry, 1, 1. When you have these sign numbers, now go back to your MSB values. When you have the sign numbers, the MSB 0 means is a positive number. Whereas, if your MSB is 1, any number, that number is equivalent to a negative number. So right now, go for the first one. The first one say that 3 is equivalent to 0, 0, 0, 3. If you look at the 0 over here, the MSB is still 0. So it's a positive number. So, times 0, 0, A, 0. This 0 MSB is equivalent to 0 is a positive number. So positive times positive equivalent to positive. That is mathematics standard berapa? Standard 4 or standard 4 dah belajar lah. That's the rules for form 2. Next one. This one okay? So multiply sign D3, D2. So look over here. D3 is given this number. 0, 0, 0. D2 is given this number. So the word size over here is 0, 0, 0, 3. Is a positive or negative number? It is positive. So look at the other one. FF00 is a negative number because of the MSB is equivalent to 1. So how do you put your calculator correctly to represent a second complement for that particular number? How? Let's say for example, you just type your calculator FF00 times 0003. What's the result? You get the same result in the computer. I repeat, use your calculator first. Try to times 0003 times FF00. Do you get the same answer with the simulator? Compare. The simulator say different. How? What is the difference? You just need to multiply a number, right? It should give the same answer. But the answer now is different because of the negative seconds complements value. So how? Let's look at your calculator. Calculator, please. I use this type of calculator. Majority of your calculators should have this type. This is confirm working. I have this one. The rest I'm not so sure, so you have to validate with mine. So now, try to use FF00. Go for XR. FF00. You convert to decimal, the number will be a positive number. No matter what. But the thing is, your PC will need to use a negative value. So how? Let's try one number. Negative 1 in second complement. So in decimal number, I have a negative value 0 minus 1. The answer is negative 1. So can you convert this one to hexa? What it will represent? So it requires 8 digits or 32 bits for the second complement to show that it is a negative number. So if I convert to hex, that number that one is a negative 1 value in second complement. So if you convert back to decimal, it will tell you that it is a negative number, negative 1. You requires 8 digits. You must use 8 digits to represent a negative number, which is all the most figure will be all F. You try another number, any negative number you can try. It will give you all the first few digits all F. 8 digits. If you don't put 8 digits, that is a positive number. So let's try another one. I have a number which is not all F, but I have only 4 FF. I convert to decimal, it is still a positive value. So your calculator must work like my calculator. Then it should be fine in the test. There are few calculators which is done